Hello students, I am Dr. Archana Sharan, Assistant Professor, Department of Physics at Bhilai Mahila Mahavidyalaya. Today I am sharing this video of Semester 4, Paper 1, that is Nuclear and Particle Physics, for your Unit 4, that is Nuclear Models. The first topic which we will be going through this unit is the liquid drop model. See, the basic constituents of a nucleus are basically the protons and the neutrons. And as we know that the shape of the nucleus is nearly spherical and its size is approximately equal to 10 to the power minus 50 meter. Now, the question arises, how are these nucleons distributed inside the nucleus? That is, uska nuclear structure kya hota hai? And how do the interactions between the nucleons occur inside the nucleus? For this, the different scientists gave their different nuclear models. लेकिन at present, no model could so far be developed which could be capable of explaining all the nuclear features of a model. Hence, each model explains only the behavior of the nucleus in some or the other specific conditions. These models are contrary to each other, and hence these nuclear models are so far given are number one, the Fermi degenerate gas model, number two, the liquid drop model, number three, the alpha particle model, number four, the shell model, number five, the collective model, and number six, the optical model. Here we shall limit ourselves only to the shell model and the liquid drop model. See, the atomic nuclei is very complex and it has a peculiar physical objectives with some of the interesting properties. And some of these properties are, that is, the nuclei have neutrons and protons. Then why do nuclei only emit alpha and beta particles? That can be a question that should come to your mind. Number two, why is the average binding energy per nucleon, that is epsilon, which is nearly constant, that is, it is approximately equal to 8 mega electron. Or why nuclei have 4n nucleons more stable than other nuclei? These are some of the questions that basically comes out in our mind to know how does a nucleon or the nucleus works. The basic difficulties in the theory of nuclear structure are number one, there is a poor knowledge of interaction force between the nucleons. Number two, there is a problem of mathematical solution. Hence, a good nuclear model should possess some of the following properties. Number one, it should describe the properties of the ground state nuclear states. That is, uska spin, uski parities, uski magnetic dipole, and the electric quadrupole moment. Number two, it should describe the properties of the excited states. That is, कि nuclear excitation spectrum कैसे होता है, क्या होता है. Number three, it should describe the dynamic properties of the nucleus. That is, जो उसकी transition probabilities होती है, gamma quanta emission में या nuclear reaction cross section, ये सब क्या होता है. There is no nuclear model which can provide a comprehensive description of the nucleus. The nuclear models are subdivided into three parts. Number one, the independent particle model, IPM, और single particle model. देखिए सिंगल पार्टिकल मॉडल में क्या होता है, द डिग्रीज ऑफ द फ्रीडम अपने आप अपने को मैनिपुलेट करते हैं when the mean free path considerably exceeds the system's dimensions. Number two, strong interaction model, that is SIM, or it is also known as collective model. देखिए कलेक्टिव मॉडल में क्या होता है, द न्यूक्लियस इज रिगार्डेड एज अ लिक्विड या फिर इट इज रिगार्डेड एज अ सॉलिड. नंबर थ्री, जो मॉडल को बाइफरकेट किया गया है, इट इज अ जनरलाइज्ड मॉडल. मतलब ये मॉडल जो है, इट एक्सप्लेन्स द पोजीशन एंड द कैरेक्टरिस्टिक्स ऑफ अ ग्रेट नंबर ऑफ लो लाइंग एक्साइटेड लेवल्स ऑफ मेनी न्यूक्लियर. हियर वी विल बी रेफरिंग टू द लिक्विड ड्रॉप मॉडल. देखिए लिक्विड ड्रॉप मॉडल, then in this the nucleus is regarded as a liquid drop and the nucleons play the role of molecules. Basically the first I'll give you a brief introduction about what is liquid drop model, and then we'll move further. The liquid drop model of the nucleus was developed by N. Bohr and Wheeler and Frenkel in the year 1937. And in this model, the nucleus is considered as a spherical drop of an incompressible superdense nuclear fluid in which the nucleons move just like molecules in the liquid. जो basic assumptions के liquid drop model के वो था number one, the nucleus consists of an incompressible matter in the radius of r is equal to r naught a to the power 1 by 3, where r naught is equal to 1.2 to 1.5 into 10 power minus 15 meter. A is the mass number. जो second assumption था liquid drop model के लिए वो ये था कि all nuclei must have the same density. Number 3, the nuclear force is identical for every nucleus. Number 4, the nuclear forces saturate, and so on and so forth. Now, in this, we'll be studying about how does the nuclear fission occurs, and based on the and how could it be explained on the basis of the liquid drop model. The fission process can be explained with the help of the liquid drop model, and in the fission reaction, the highly energetic neutron to be bombarded on the nucleus to form the highly energetic compound nucleus, and its extra energy is due to the binding energy. इस process को explain करने के लिए we use some basic property of liquid drop model. According to this model, a nucleus can be assumed like a liquid drop. This model is based on the following three features of the nucleus. Number one, the nucleus is filled with incompressible substance. जैसे मैंने आपको भी बताया कि the density of the nucleus matter is very large. मतलब वो इतना ज्यादा होगा that the substance becomes incompressible. Number two, there are short-range, strong nuclear forces among the nucleons, and each nucleon experiences the same nuclear force. And number three, the nuclear forces are saturated. Obviously, the nucleus cannot be assumed like the crystalline array of the nucleons, and hence this is the reason that in some of the cases, the vibration of the nucleons on either side of their mean position will be either too strong that the nucleus will not remain stable. Hence, it was assumed that each neutron inside the nucleus moves just like the motion of a molecule in liquid. The nucleons inside the nucleus with the intermolecular forces को हम cohesive forces भी बोलते हैं. This is why the nucleus is considered like a small drop of liquid, and this model is called the liquid drop model. Basically, the spherical shape of the drop of the liquid is due to the surface tension force on similar way. The spherical shape of a nucleus is due to the strong force that is acting between the nucleons. The surface tension forces maintain the spherical shape of a drop of a liquid, while the excitation energy tends to distort its shape. And in similar manner, inside a nucleus, two forces play important role. दो forces हैं जो बहुत important role play करते हैं एक nucleus के अंदर. उस पहला हो गया आपका Coulomb force, मतलब it gives a distorted shape. And number two हुआ आपका strong force, जो कि वो अलग अलग nucleons को restore करता है अपने original shape में. See, here's a diagram that explains how a nucleus gets converted into a liquid drop. If the Coulomb force is dominant over the strong force, it distorts the shape of the nucleons. And the second condition is if the strong force is dominant over the Coulomb force, it restores its original spherical shape. But what happens if the oscillation is violent? Then the stage fourth is reached. That is, the final fission occurs in the fifth stage. Thus, there is a threshold energy. Threshold energy क्या होता है? Threshold energy is the maximum energy required to produce fourth stage, often which the nucleus cannot turn its previous stage. Hence, it is assumed that if in any nucleus z square upon a is greater than equal to 10 to the power minus 30, then the self distortion of the nucleus occurs. But experimentally, it is not possible. The potential energy of the drop in the different stages can be calculated as a function of degree of formation of the drop. See, here's a graph which is plotted against R, the separation of the centers of fission fragment, and the energy. And the curve here is following. We see that कि जैसे जैसे एनर्जी के तरफ हम जा रहे हैं वैसे वैसे what happens, the R is getting more broadened. It means that जैसे जैसे हम उस पे एनर्जी लगा रहे हैं the nucleon get distributed into the fragments, and this is the fission that happens, and it is explained on the basis of the liquid drop model. Hope this video helps you in your um, reading, and uh, if and thank you so much for the